One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and is the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, welcome back to the podcast. This is episode 3 in a mini-series where we're still talking about health and longevity. And today we're going to talk about some of the molecular mechanisms of aging and loss of resilience. And we started out by talking about aging in general as a process of gradual physiological deterioration that happens over time. And it's important to understand that it happens at different rates in different systems or tissues. So it's entirely possible that your liver is biologically younger than your brain, or you might have a biologically younger thyroid gland compared to your gut, and so on. In the last episode, we talked mostly about resilience, and we defined resilience as the ability to take a hit and to keep on going, meaning that as you age, your body is exposed to a myriad of both internal and external stressors that can cause damage and dysfunction at the cellular and even molecular levels. And your ability to withstand that and to maintain balance and control of function is absolutely essential to healthy aging. Back in 2016, a group of Harvard researchers said that the dynamic interplay between a living organism and its environment determines the rate and the fate of aging. And they also said that the ability of an organism to overcome stress and respond to external environmental challenges and insults is blunted, or it's reduced, in aged individuals compared to their younger counterparts. And so this ability to withstand the aging impacts of stress is what we call resilience. And in the last episode, I went through a list of things to look for in different body systems to see if you can spot signs of loss of resilience in yourself. And it's probably a good time to remind you of a few things. Number one, when I use the word stress, I'm using it in the broad and the general sense of anything that can shift your system out of balance. And that includes not just psychological stress, but physical stress as well as physiological stress. And we often think of stress as an outside thing, something that's imposed on us from the outside. And yes, research certainly shows that the environment that we live in presents multiple chronic stressors to which we must always respond and adapt. And these would be things like heat and cold exposure. We would also include things like air pollution or radiation, and even toxins in the water, in the air, and the food that we eat. But stress can also be generated from the inside, right? From the internal environment. And inflammation from chronic infections or from some kind of autoimmunity, for example, would be internal stressors, as are things like changes in your blood sugar control or hormonal imbalances or leaky gut, just to name some of the more common things that people talk about these days. And in reality, even the toxins and the waste products of normal cellular metabolism are chemical stressors. And that if we don't break them down and clear them out, they can cause damage to cells or to cell parts, or at least they can disrupt normal physiology. So one of the main things that I want you to understand about aging and loss of resilience is that this happens at a cellular and a subcellular level, right? Aging and loss of resilience is characterized by the accumulation of molecular and cellular damage. And that leads to structural and functional abnormalities in the cells and the tissues that make up our glands and our organs. And to go through these just really quickly, these include things like damage to the mitochondria, which leads to decrease in energy production. We can also see impaired intercellular communication, right? Communication between cells. And this is a critical piece because you need to know that cells don't function in isolation, right? We might talk about pancreas cells or brain cells or liver cells. They all work together. And so not only do cells work in conjunction with other cells of the same type, but they also communicate with cells of different types that do different things. And if we are to expect to be healthy and to age well, to increase our health span and not just our lifespan, it's essential that cells communicate with each other, and this communication goes wonky when we lose resilience. We also know that we sustain damage to our DNA. We've talked about this before. Of course, that's never good, right? It changes the code that determines cell health and cell function. Imagine trying to bake a cake where someone swapped an ingredient in the recipe. Say they exchanged gluten-free flour and replaced it with sawdust, right? It would completely change the characteristics of the cake. I don't think you could call it a cake at that point. And that's part of what DNA damage does. It replaces information that your body and your cells use to determine structure and function. And then finally, when we lose resilience, we lose control of senescence, right? Where older and damaged cells don't stop dividing and die off when they should. And that means essentially two things, right? They pass on faulty DNA to the next generation of cells. And because they live longer than they should, they simply hang out with their damaged DNA, their damaged mitochondria. And over time, we accumulate more old dysfunctional cells in our cells, our tissues, our organs, and our glands, right? So the glands and organs themselves become faulty because they're made up of cells that should have been replaced and haven't been. And both of these things impair our regenerative capacity. And at some point as we age, we simply can't refresh and renew our cells like we used to. Let me pause and just kind of change gears for a second. I want to give you a few more stats on some trends in longevity. In the United States in 1995, 1 in 20 million people lived to be 100 years old. That's what we call a centenarian, at least 100 years old, right? So in 1995, it was 1 in 20 million. But today, and we're at the end of 2023 right now, that number is 1 in 5,000, right? That's a massive increase in how long we live. But remember that increase in longevity is not matched by an equivalent increase in health during those extra years. And so we have a lot more people living to the age of 100 and beyond, but most of them tend to have more disease and more dysfunction. So we live sicker longer. Just because you're living older doesn't mean you're going to be healthy. Now, in other countries like in Sweden and Japan, the number is like 1 in 50 people who will live to be at least 100 years old. And obviously these are going to be reflections, not necessarily of genetics, but of things like diet and lifestyle and environment, of course. Universally, women live longer than men do. And it's like the difference is so stark that in the United States, between the ages of 50 and 75, the difference between the number of females compared to males roughly doubles, right? So between 55 and 75, there's roughly twice as many women as men. And once you hit 85, that number doubles again, which is kind of crazy when you think about that. And in this final topic here, like research in this particular area is a little bit conflicting, but some studies equate longevity to things like fertility and childbearing. So we have studies, and again, there's conflicting evidence here, right? So we don't know exactly how this works, but there are some connections. But we know that middle-aged mothers live longer than middle-aged women who have no children. And women who were older when they had their last child tend to live longer than women who had their last child when they were younger. And simply being a caregiver, as in being a mother, caring for other little human beings, motherhood is correlated with increased longevity, right? And this would probably fall under the general category of community or support and love, things that have very profound effects on the health of your brain, your hormonal balance, and particularly the competence of your immune system. We also know that from gene studies, certain gene mutations can have a pro-longevity effect. One gene that's gotten a lot of conversation in the last decade or so, something called ApoE. It stands for apolipoprotein E. This is a lipid carrier, and basically it comes in different varieties. And we'll talk about ApoB in some upcoming episodes on brain health. But for now, know that the ApoE4 variant, because you can have a 2 or 3 or 4 and you have pairs, so you can have an ApoE profile of 2-2 or 2-3 or 3-3 or 3-4 or 4-4. But the ApoE4 variant, which is the one that everyone's talking about because it's associated and correlated with an elevated risk for Alzheimer's, we don't see that much in people who live to be 100 or more, which is kind of interesting, right? So it's probably important for you to know what your ApoE profile is. And again, we'll talk about these things in future episodes. But also, we know that certain gene variants in chemical signaling pathways, particularly the insulin and IGF-1 pathway, these pathways control cell tissue growth. Certain variants are also associated with longevity. But, when we start talking about genes and gene studies and signaling pathways, it gets very sciencey and sometimes a little bit complicated. But the bottom line is this, is that being insulin sensitive and having low insulin levels is not just good for your overall metabolic health, it actually extends your life. And because you're improving your metabolic state, it increases your health span, right? Being healthy for longer periods of time. But despite some of the evidence that genetic influences can positively affect longevity, environmental factors exert even greater effects. And according to some of the twin studies in this field, roughly, let's say no more than approximately 25% of the variability in the human adult lifespan can be traced back to genetic differences, right? So, do we tend to see longer lived people in certain families? Yeah, so there is some heritability there, but it's the minor influence. Much more profound is the influence of things like behavior, your choices, your lifestyle, the environment you live in, how your body reacts to those things. Essentially, the things that you practice for health and well-being have the most profound effect and the potential to not just extend your lifespan, but also your health span. So genes play a role, but it's like a weak variable compared to all the other things. And if you recall in my introduction, I asked a question. Like the question is, how do we die young as old as possible, right? And to translate that is, how do we retain resilience as we age? Because when we lose resilience, we age faster. That's the connection. So I thought I would approach this in the spirit of that phrase, molecules to man, the phrase that I quoted in the introductory episode. And I want to start in this episode by talking about some of the molecular mechanisms that control senescence or cellular aging. And then we can talk about some of the large-scale variables that you can implement, which will be in the following episode. So let's talk about some of the molecules of longevity. We're going to start with a class of molecules called Sirtuins. Now, we're going to go through a couple of things and just understand that there's more to the story of longevity at a molecular level than just the things I'm going to share with you in today's episode. But these are some of the things that have been studied more than others. And these are things that tend to float to the top of priorities. These are the things that clinicians and researchers and even drug researchers and supplement companies look to these types of things that we're going to talk about now as indicators of what we can harness and what we can do both clinically and also in our personal choices to try to improve resilience, try to improve health span and longevity. So let's talk about sirtuins. Sirtuins are a class of intracellular enzymes, right? Enzymes inside your cells that basically control every aspect of cell aging. You might remember in the introduction, I gave you a list of 9 hallmarks of aging. I'm not going to go through those again, but these sirtuin compounds control at least 2 of these 9, but specifically they control what's called telomere attrition and the DNA repair process. And I'll explain that in a moment. In addition, these sirtuins control senescence itself in the sense of controlling the cell replication cycle, that thing that has that thing called the Hayflick limit, where a cell divides roughly 50 times before it stops and goes through some kind of a programmed cell death process. We also know that sirtuins interact with several lifespan regulating pathways, including that insulin IGF-1 pathway I mentioned earlier, as well as another key pathway, which I've mentioned briefly in, in previous episodes, called the AMPK system. And essentially, the AMPK pathway it's the master switch inside your cells that controls metabolism, and it's an energy and nutrient sensing system that exerts control over things like insulin and glucose and fat utilization. So it determines how your cells behave when it comes to energy sufficiency. In mammals, as a lot of these studies are done, especially with longevity, this is probably an important thing to know, is that most of the information we have on longevity and even the impact of things like intermittent fasting strategies, these are done on bugs and yeast in labs. There's very little information, especially in comparison, about longevity and the impacts of things like intermittent fasting in humans. Now, we have a general belief that if we study something in a yeast or a specific species of a fly or a mosquito, or if we do this in animals, whether that's rats or dogs, for example, obviously whose lifespans are shorter, so it's easier to study longevity concepts and things that impact that in things that don't live very long. Like, so again, you're not going to see a lot of human studies on these things, but we have this general belief, well, if it's true in other mammals, for example, it's probably true in humans as well. But that is an assumption. And I'm not saying don't trust all the research that's out there. I'm just saying just be aware that there's a little bit of a gap between what we know happens in other mammals and other types of creatures and what we can actually demonstrate and prove from a research standpoint with human beings. But having said that, we're just talking about in mammals, there are 7 types of sirtuins that live in different parts of your cells, and they play different roles. So for example, some sirtuins live in the cell cytoplasm, which is kind of the liquidy part of the inside of the cell. Some live in the mitochondria, that's the energy producing factory, and some live in the nucleus, and that's where your DNA lives. Some sirtuins control the cell replication cycle, while others play roles in things like energy metabolism or DNA repair. And some help your cells resist stress and control the influence of epigenetic factors of diet, lifestyle, and environmental stressors that can change how your DNA behaves. That's what an epigenetic factor is, something that changes how your DNA works. And one other critical function of sirtuins is the protection, not the production, the protection of something called telomeres. Now, you may have heard of telomeres. They're a pretty hot topic right now and have been around. Gosh, I can't remember the first time I heard about telomeres. It was probably 20 or so years ago. And it takes a long time for things to show up in research and then to filter out into the medical community and, out into general population. But nevertheless, telomeres, hot topic right now, especially in the field of longevity. Essentially what a telomere is, they're caps on the end of your chromosomes, and chromosomes basically it's a long strand of DNA, right? So essentially the same thing, but technically a little bit different. But your DNA lives inside this thing called a chromosome, and these telomeres are part of the system that controls senescence. And just to give you a mental picture, telomeres are often compared to the plastic caps at the end of your shoelace. Right? These things are there to protect your shoelace from splitting at the end and fraying and unraveling to the point where your shoelace becomes unusable. And that's what a telomere is. It's a cap on the end of your DNA strands that protects the DNA, right? And so by design, every time a cell divides, these telomeres, these end caps, they shorten. And after that Hayflick limit of about 50 cycles of cell replication, the telomeres become too short, and that triggers a cell death cycle, and so the cell goes away, and that's a good thing. Remember that we don't want old cells with DNA or mitochondrial damage to hang out too long because they continue to divide beyond the point where they should. They pass their damaged DNA on to their children. So essentially the telomeres, as they continue to shorten every time a cell divides, acts like a timer, let's say on an explosive, right? When the timer runs down to 0, essentially the cell blows up. And so we know that telomeres protect DNA itself. And without these telomere end caps on your DNA, the end of the DNA literally would fray and your DNA would come apart. And your chromosomes and your DNA would then be damaged, and all kinds of things could happen. So for example, you could have 2 DNA strands that link together and they can become a tangled clump, and essentially the DNA at that point doesn't work, or at least doesn't work the way it was designed or expected to. So we want telomeres to shorten over time, but we want that to happen in a controlled manner, like that time-delayed fuse or a timer on an explosive, so that each cell dies after it's lived its useful life. But we don't want them to shorten too quickly, because telomeres can be damaged. They can break down too quickly, and that exposes the underlying DNA to damage and dysfunction. And the main thing that shortens telomeres too much is, you guessed it, inflammation and oxidative stress. Which, by now you should understand that inflammation and oxidative stress are interlinked. And you should also know that oxidative stress is primarily generated by your own mitochondria, the thing inside your cells that makes the very energy that your cells need to work. And so this means that any diet or lifestyle choice you make that reduces inflammation and oxidative stress, or that improves mitochondrial function, should have a favorable impact on your telomeres and therefore your aging. Right? Smoking and obesity have very clear relationships to premature telomere shortening and both mitochondrial and DNA damage. And while not all obese people are metabolically deranged, the majority are, and they probably fall within the domain of cardiodiabesity, that intersection of carrying around too much body fat, having heart disease risk, and perhaps having diabetes, or at least you're progressing towards that. And so that means that simple things, like things that we know, like stopping smoking, losing weight, controlling blood sugar, reducing inflammation, these are key strategies. But that doesn't mean that if you're a lean non-smoker, you're going to get off scot-free, right? There are many paths to inflammation and oxidative stress, and therefore telomere damage, and your overall metabolic health is very critical. Now, one of the cool things about how your body has been designed is that while your telomeres sustain damage through inflammation and oxidative stress, there is also a telomere repair system using an enzyme called telomerase. It's kind of hard to say that. Telomerase or telomerase. It depends on how you want to pronounce it. So when a cell divides and the chromosomes lose a piece of the telomere, they shorten, or when the telomeres get damaged from oxidative stress, then this telomerase comes in and it repairs that damage. And this dual feature, where we want telomeres to shorten but under control and to be repaired from things that shorten prematurely, is how we control aging. But everything has a downside, right? Like I said, if we lose control of telomere shortening, cells live too long, and that's bad. Likewise, if telomerase doesn't allow shortening over time and cell death to take place on schedule, that's bad too. And this prolonged activity of telomerase can lead to increased cell division without cell death, and that's basically what we describe as cancer. So if you've been trying to piece it all together as we go along today, you might be asking, hey, well, what can I do? Like usually people ask, what supplements can I take to improve my sirtuins and to improve telomere length by maybe supporting the telomerase? And the science here is pretty strong. It's strong enough that, again, companies make nutritional formulas specifically for this purpose. And there have been billions of dollars spent in the research world trying to find drugs that increase longevity. But listen, before you hit Dr. Google and you start popping telomere support supplements, please understand that the most powerful drivers of longevity, of sirtuins and telomere repair, even your insulin and your AMPK signaling pathways, the most powerful drivers are not found in a plastic bottle, right? They're found in the grunt work of having an ideal diet for your body chemistry, controlling carbohydrate intake, and promoting insulin sensitivity, getting enough sleep, reducing and controlling stress, and yes, even that dreaded four-letter word called exercise, which obviously has more than four letters. Now, I've said it a million times, and I'll say it a million more. You can't out-supplement a bad diet. You can't out-supplement a crappy lifestyle. If you're stressed and sedentary and you can't sleep and you're eating too much sugar and carbohydrates and your insulin's not under control, you cannot expect any supplement to extend your lifespan or health span until you get those things in place, until you get control of those things. Now, having said that, I do want to give you a short list of nutritional supplements that have been linked in research to increasing sirtuins and telomeres activity. Remember, this is what translates into maintaining control over senescence so that cells stay functional longer and die off when they're supposed to. There was a paper published in 2019 in the journal Molecular Medicine Reports. It looked at several different natural compounds and their impact on telomerase activity and their ability to protect and repair these damaged telomeres. And the top 3 performers in order of potency, number 1 is an herb called gotu kola. It's also known as Centella asiatica, and it's often used to improve blood flow to the brain, for example. Also another compound called oleanolic acid, which is found in high-quality olive oil, and an herb called astragalus, which is quite often used for its antiviral properties. Whether you have a cold or a flu, astragalus is commonly prescribed for that. And so these 3 natural compounds, gotu kola, oleanolic acid from olive oil, and astragalus, are shown in the literature to increase telomerase activity anywhere from 4 to 9 times over the baseline. Now remember, just taking these as supplements is not going to overcome the impact of having bad diet, bad lifestyle, not controlling stress, not sleeping, etc. Now, as far as sirtuins go, most of the research focused on 2 related compounds, and those 2 things are resveratrol and pterostilbene, and that's pterostilbene that starts with a P, but the P is silent. So pterostilbene. I'm sure you've heard of resveratrol. I've talked about it in different episodes before. It's an extract from the skin of red grapes. And it's not just a sirtuin activator, but it's a great anti-inflammatory agent as well. And I use this quite often with my chronically ill and especially autoimmune clients. But it does have some drawbacks in that resveratrol, especially in capsule form, has very low bioavailability and a very short half-life, which means that if you just buy resveratrol, at Costco or some random seller on Amazon because you're trying to save money, chances are you're not getting the quality that you need or the doses that are going to work for you. So be very careful buying stuff online. There is also this resveratrol-like substance that comes from blueberries, and this is the pterostilbene. And it's an analog of resveratrol that has 2 advantages. First, it's more bioavailable than resveratrol. And second, it's got a much longer half-life. So with pterostilbene, it's easier to get the dosing that you need to make a difference. Not that resveratrol is bad. It's got a ton of research and a much longer track record behind it. So let me reiterate, I know it's tempting to simply go out and buy supplements for this and that, right? This is the downside of, guys like me doing podcasts or posting stuff like this on social media. It kind of creates the sense that you have to be taking these supplements. And if you're not taking care of yourself. But again, let me reiterate, first and foremost, if you're unwell and have metabolic imbalances, your lack of longevity, if that's a problem, is first and foremost tied up in your general metabolic state. So before you put yourself on an anti-aging supplement protocol, you first must clean up the things that are reducing your health span before you worry about your lifespan. Remember that the goal is to die young, as old as possible. Aging will happen. It is inevitable. But true health and wellness has to be crafted, right? Don't put the cart before the horse by focusing on, lengthening your telomeres when what you should be doing is cleaning up your diet, exercising consistently, improving your stress chemistry, balancing your hormones, fixing your leaky gut, reducing your insulin levels and controlling blood sugar, optimizing your thyroid and your brain. Right? It's so much easier to pop a pill or even a supplement and convince yourself you're doing right by yourself, and it's so much harder to do the grunt work. But I'm telling you that the grunt work is where 80% of your results are going to come from. Supplementation for supporting sirtuins and telomeres has to take a backstage to the center stage stars of the show: diet, lifestyle, and metabolic control. All right, so that is the molecules aspect of the molecules to man progression, going from the small detail view to the bigger picture. Next time, we're going to talk more about that big picture, things that research tells us that we can manipulate to improve longevity. But before I go, please make sure you subscribe to the podcast. And if you're struggling to piece all of this together, why not use one of the links in the description? You can reach out to me. You can schedule a one-on-one consult. Listen, the new year is right around the corner, right? And that means that most of us are going to be thinking about resolutions and the whole new year, new me part of winding down 2023 and heading into 2024. So if you're serious about finding and fixing your metabolic issues so that you too can live healthier longer, then I would love to talk and help you in any way that I can. So you can just hit the link in the episode description, or you can go to my website, drnoseworthy.com. That's drnoseworthy.com. There's a contact form there. Just look for the menu up top. Go straight to my email, and yes, I will answer you personally. The countdown is on. 2023 is ending. 2024 is right around the corner. All right, guys, I'll see you next time. Thanks for listening.
Thanks for listening to Inflammation Nation. If you enjoyed this episode, make sure you subscribe to our podcast. Be the first to know when a new episode drops so you can stay on top of your game. It also helps others like you find the answers they need. You can use the links in the episode description to check out Dr. Noseworthy's self-learning programs for thyroid, detox, and gut health. Or you can submit a question for the podcast and even reach out to Dr. Noseworthy directly.